we're on to question 2. And question 2 is a complex numbers question. It starts off nice and easy. It says the complex number Z1 is -2. So -2 plus 0i. And Z2 is equal to -1 plus 2i. They're plotted on figure 1 on the Argand diagram for the complex plane with Z equals x plus yi. Okay. It says plot Z3, where Z3 is equal to 1 plus I on the Argand diagram above, and ensure the point is clearly labeled. Well, this is an easy question once you just look at it for a moment. That for every 2 boxes is 1 unit. So we're 1 out and 1 up. So this is the point 1 plus I. Okay. So if your 2 boxes is 1 unit, we can judge that from Z1 and Z2. Okay. It then says find the modulus of Z2. So the distance from Z2 to the origin. So this is what we're looking for here, the distance of that line. So we can do it using Pythagoras' theorem, knowing that this is a distance of 1 unit and this is a distance of 2 units. So what are we going to say here? We're going to say, well, you can say r is equal to the square root of the real part squared plus the imaginary part squared. Or you can think about it as this is the distance of 1. This is the distance of 2. So it'll be the square root of 1 squared plus 2 squared. And that turns out to be equal to the square root of 5. So that's 2 5 markers so far. So we're up to 10 marks. And you'll be hoping everyone will be up to 10 marks for that part. Now, this next part was more difficult. And this one would be a part that would have turned some people off from this question. Okay. So I'm going to do it in 2 ways. I'm going to write one way out here. So if I, you know, as I always kind of say, if you don't know what to do, do what you know. So you could be looking at this question and you might say, it says, show that the arg or the argument of Z2 minus Z1 divided by Z3 minus Z1 is equal to pi over 4. And you might say, well, I don't know how to do that. But look, you do know how to simplify down what's inside in this bracket. So Z2 minus Z1, well, here's Z2, here's Z1. Z2 minus Z1 is going to turn out to be equal to 1 plus 2i. Z3 minus Z1 is going to turn out to be, well, that's 1 plus I, and then it's going to be minus 2. So I think that's going to end up as 3 plus I. And what am I going to do then? Well, we know if I've got a complex number divided by a complex number, what do? I multiply by the conjugate of the denominator. I multiply above and below by the conjugate of the denominator. And when I do that, when I do this multiplication, what am I going to end up with? Well, it turns out I think I'm going to end up with 5 plus 5i over 10. And that's going to be end up with, you know, a half plus a half I. And on our diagram here, that would actually put me here, wouldn't it? A half plus a half I. And if I was asked for the argument of that, well, what is the argument for a half plus a half I? Well, in this case, just in case you're not familiar with the terminology, the argument is going to be your angle alpha. So alpha, what I can say, the tan of alpha is going to be equal to the opposite, which is a half, over the adjacent, which is a half, because that length here is a half and this length here is a half. So a half all over a half, which obviously is equal to 1. Any number divided by self is equal to 1. So tan of alpha is equal to 1. So alpha is equal to the inverse tan of 1. So alpha is equal to 45 degrees or pi over 4. And what's that? Pi over 4? Pi over 4 radians. Okay, so, you know, you could have do it that way, no problem, full marks. And you mightn't have been sure what you were doing at the start, but just by working your way through those steps and getting down to a half plus a half I, you might then think to yourself, okay, argument, polar form, get the angle. And before you know it, you have the answer. And you still mightn't be 100% sure what the question means, but you have the answer to the question, which is the most important. Now, another way of doing it is as follows. Okay. So we can say the argument of z2 minus z1 divided by z3 minus z1. Well, in this complex number in polar form, I know that's equal to the arg of z2 minus z1 minus the arg of z3 minus z1. So again, now I'm going to do my little bit of maths here. z2 minus z1 is going to end up as 1 plus 2i. So here it is. I plotted it here. This is my z2 minus z1 over here. Let me get a highlighter. z2 minus z1 here. Now, when I'm talking about the argument of it, well, I'm saying again, the tan of, if I call this guy, you know, typically you call it alpha. So, well, actually, what am I saying? Typically you call it theta. So I can say this is theta here. So I can say the tan of theta is equal to the opposite over the adjacent, 2 over 1. So therefore theta is equal to the inverse tan of 2 over 1. So it's the inverse tan of 2. Okay, so we can say the argument of z2 minus z1 is the inverse tan of 2. Now that turns out to be a decimal answer. Okay, I can do the same thing here for my next guy. I can say z3 minus z1 turns out to be 3 plus I. Okay, so that's my point here, 3 plus I. And again, I can get the angle. So again, you know, for this particular one, I might be calling this guy theta here in this case. And I'd say the tan of theta is equal to the opposite over the adjacent. So therefore, theta would be equal to the inverse tan of 1 over 3. So there we go. The argument of z3 minus z1 is equal to the inverse tan of 1 over 3. So therefore, putting it all together, I can say the argument of z2 minus z1 divided by z3 minus z1 is equal to the inverse tan of 2 minus the inverse tan of 1/3. And when you put all that into the calculator, make sure you're in radian mode, it's going to throw out the answer, which is pi over 4. So, okay, there was 2 different ways of doing it. And you might be scratching your head at the end saying, yeah, geez, that was, you know, I got the answer. I'm not even sure how I got the answer. But you got 10 marks. And, you know, it's a funny little question, you know, but there you go. You end up with the answer that you need. And it corresponds to this part in there, that little purple segment. Okay, let's keep going. Here's the good news. The very last part of the question after that tricky little part C is actually just a very straightforward polar form. It actually just says write Z3 in polar form. So again, you can see this theme with the exam, that oftentimes the last part of the question is easier than some of the earlier parts. In this case, I've got to find the modulus. So the modulus is the square root of the real part squared plus the imaginary part squared, or you can think of it as Pythagoras' theorem. You get root 2. What happens next? I'm getting my, you know, again, I'm going to call this theta. So I'm going to say the tan of theta is equal to 1 over 1, which is 1. So theta is equal to the inverse tan of 1. And so over here, I'm saying it's like the argument of Z3 is the inverse tan of 1 over 1, which is equal to pi over 4. So we're in radian form, radian mode. Why? Because it tells us that in the question that we're saying 0 is less than or equal to theta is less than or equal to 2 pi. And so here's my answer. It's in the form of or cos theta plus I sine of theta. It's root 2 times cos pi over 4 plus I sine pi over 4. That's it for 10 marks. And so that was a nice little easy 10 marks at the end to get. Okay, that's the end of question 2. Let's get on to question 3.